Alright, so picking up where we left off, the next thing we were doing is arc length and area. Somebody tell me what the formula for arc length is.
S equals R theta.
What does theta have to be in?
Radian.
And what about for area? What's the formula?
Units squared.
Half of r squared or a equals half. 1/2 r squared theta. I can't speak.
Yep, or 1/2 RS. So once we found arc length, we would just use this 1/2 RS one. It makes it easier. So, let's see, 32. R equals 4 inches and theta equals pi over 6. So it wants arc length and area. So S equals R theta. So S equals 4 times pi over 6. And so you would multiply that out and get a decimal answer to 2 decimal places. So that gives us 2.09 inches. Then I use this number here for area. So area equals 1/2 times 4 times this number. And on your calculator, when you have the answer that you just used and you're multiplying it by something else, just hit multiply and it keeps the answer, so it keeps your, like, you're not using a rounded answer then to do it. And we get 4.19 inches squared. So area is still units squared for this stuff. Let's see, 36. R equals 18 meters, theta equals 25 degrees. So what do I need to do to start with?
S equals 18 times 25. You gotta change it to
Degrees
radians.
Gotta change to radians first, so how do I do that?
You do the T thingy.
Pi over. I don't have close.
Yep, pi over 180. If you want, obviously normally we just reduce these things and keep it in terms of pi, but if you want to go ahead and get a decimal, since ultimately we're going to be multiplying it through and getting a decimal like we did up here, that's fine too, however you want to do it. So when I do that, just as a decimal, this is 0.44. So S equals 18 times 0.44. And again, I'm going to use the unrounded number here. I'm going to use this number and just multiply it by 18 to get 7.85 meters.
So will we always have our calculators for these problems? Okay.
You pretty much have your calculator for everything. It's just some of the problems are going to say, like, you can't use it, meaning I want the, like, exact answer. So, like, the
Right.
stuff off the unit circle. Like, you're going to tell me it's root 2 over 2, not 0.707.
Okay.
But that's really the only thing. Like, there's really nothing else that I'm going to be, like, when we do inverse trig, like, kind of the same thing. You're going to have to give an exact value. So even though you have your calculator and it can give you the answer, you're still going to have to give the value off the unit circle. So then area 1/2 times 18 times 7.85. Again, I'm using the unrounded number. So I get 70.7 0.69 meters squared. All right, and then the last stuff in this section is evaluating the trig functions, and it says to use a calculator only if necessary. So basically, if it's a number off the unit circle, we're not using it. Now, obviously, we only have sine, cosine, and tangent directly on our unit circle, okay? But if it's an angle that we know, we also can do secant, cosecant, and cotangent, okay? So, starting off with this one, number 40, the sine of pi over 4. What is that?
Oh. Root 2 over 2.
Root 2 over 2. All the pi over 4s are root 2 over 2. It's just a factor of where it is, if it's positive or negative. Let's see. Now, if we have one like this, 42, the secant of pi over 9. Is that something on our unit circle? No.
No.
So, what I need to do is I need to, one, make sure my calculator's in radian mode. Okay. And then 2, I need to type this into my calculator as 1 over the cosine of pi over 9. Okay, because secant is 1 over cosine. So, I was in degree mode. So, always check your mode first, because it'd be really unfortunate to get a problem wrong just because you're in the wrong mode. So, remember, we look at mode. We go down here. Want to make sure radian's highlighted in this particular case. And then we do 1 divided by the cosine of pi over 9. And I get 1.06. And there's no units on one like that. (44) The cosine of pi over 6. What's that?
One half. 2 root 3 over 3.
This is a value straight off the unit circle.
1/2. Root over 2. Root 3 over 2.
Root 3 over 2. Cosine's the x value.
Oh, I have that written. I didn't look at it.
All right, what if they don't give a ton, but I just want to do a few examples. What if they ask us for the cotangent of 2 pi over 3? How would I have to think about this one?
The 1 over the tangent?
Yep, think about it as 1 over the tangent of 2 pi over 3. Now, what's the tangent of 2 pi over 3?
Negative root 3.
So this is 1 over negative root 3. Need to rationalize it, so what do I end up with?
1 root 3 over 3. Negative root 3.
Yep, negative root 3 over 3. Now, the other thing I'm going to show you here really quick with this unit circle is that when I do the tangent values, okay, the cotangent at 45 degrees is the exact same as the tangent at 45 because 1 over 1 is just 1, okay? Now, for the pi over 3s and the pi over 6s, the tangents and cotangents are flipped, okay? So these values here are tangents, the cotangents would be flipped. Okay, so obviously you can do the math, but you can also just know that they're going to be flipped when you do them. So, like, at the increments of pi over 3, cotangents are root 3 over 3. Again, positive or negative, depending on where they are. And at pi over 6, the cotangents are root 3. Okay, so if you want to memorize it that way, that's fine, or you can do the math every time. I'm going to be honest, I end up doing the math a lot because I just don't think about, oh, let me just flip them. So, Now, if we had, let's see, the sine of 5 pi over 6. And obviously, we're working in radians right now, but obviously, same would work if they gave us degrees. I think all these problems give us radians, though.
At 1/2.
Okay, so the sine of 5 pi over 6 is 1/2, yes. Now, if instead I said the cosecant of 5 pi over 6, cosecant is what?
Cosine or 1 over.
1 over the sine.
1 over sine. So 1 over the sine of 5 pi over 6. So that means that this bottom is 1/2. So 1 over 1/2, which is 2. And you're going to notice patterns with these two. If I did another one that's something over 6, the cosecant's going to be 2. Right? Let's see. The secant of 11 pi over 6. What would that be associated with?
Cosine.
1 over cosine of 11 pi over 6. What's the cosine of 11 pi over 6?
Root 3 over 2.
Yep, so 1 over root 3 over 2. So then when I keep change flip, I end up with 2 over root 3, which I've got to rationalize. So these end up being 2 root 3 over 3. So all your answers, like, you should never have anything other than essentially the numbers 1, 2, and like, or root 2 or 3 or root 3. Okay, basically if you have any number other than 1, 2, or 3, you've probably done something wrong. And obviously they can be under a radical, whatever. But, like, you shouldn't have any other crazy numbers. Don't get, like, the square root of 5 and be like, the secant of this is the square root of 5. Like, that's not possible. So, just be aware of that, which, again, that'll be more, like, relevant later on. But any questions about that or how to use the unit circle or anything like that? All right. So then I gave you some problems the other day. Obviously, we stopped at 29. So let's see. We need to add on uh 33, 35, 39, 41, 43, and 45. And you need to make sure that your 13.3 notes are done for tomorrow. And that's technically, 13.3 is technically when they normally teach you the unit circle, so section actually probably won't take us as long as I thought. Don't forget your first practice quiz for the unit circle is on Wednesday. So just be aware of that. Does anybody need an extra copy of a unit circle for practicing? Just Zach? Jeannie? Okay.